my KCET 2026 aspirants. So how are you all? And I hope all of you have started your preparation with full fledged for your KCET 2026. So now you might be like in your classes, you might be having some backlogs or you are studying regularly, but please remember this, that you have to be consistent throughout this 1 year for your studies to get a top rank in KCET 2026. I have been teaching in KCET for the last so many years, and I have observed that students generally take KCET very lightly, and at the end they rush for it and they are not able to get good rank. So please don't underestimate KCET examination and start preparation right now with us. Every video you have to watch, every questions you have to solve, then definitely you will get a very good rank and you will be in the top colleges of Karnataka. So as we have been starting with different chapters. The first 3 parts have already been completed in your electrochemistry chapter, right? And today we are in part 4, okay, where we will be talking about electrolytic cells and electrolysis. Okay, so you have to be very consistent with me. You have to be watching the full video to understand, to have a complete grip over this particular concept. Okay, so we have already covered part 1, part 2, part 3, and now we have today part 4, where we'll be talking about electrolytic cells and electrolysis. Okay, so let's see what we have in today's, I can say, spotlight, that is your electrolytic cell, quantitative aspects and products of electrolysis. Okay, these 3 topics are there, not very big topics, but yes, very, very important from the exam point of view. Fine. So now let's talk about electrolytic cell. So we have studied in the first class only what is galvanic cell, what is electrolytic cell. Electrolytic cell is that type of cell which connects or which converts electrical energy to chemical energy, as a result of which a chemical reaction can happen. Repeat with me, electrical energy to chemical energy, that results into a chemical reaction. Electrical to chemical, electrical to chemical, right? So now we have, all of you please comment down electrical to chemical, so that you have a quick understanding what is a electrolytic cell. Okay, now we have something called as, it considers of a non-spontaneous reaction. Now I'll give you a very, very simple example for non-spontaneous reactions. Just compare studying. To make you study, how many people put how much efforts? Your teachers have to force you, your parents have to force you, your tuition teacher has to force you to make you study, right? But if I arrange a football match in your school, or if there is a football match somewhere, do you have to be forced by anyone, or you just put alarm by your own, pack all your things and just run away to play the match? So you are getting the difference between spontaneous and non-spontaneous. In football match, nobody has to do no effort. You can do that work by your own without any external force. That is called as a spontaneous process. What is non-spontaneous? Study, where so many external things are needed to push you to do that work. So in this electrolytic cell, the chemical reactions, okay, they doesn't occur by their own. You have to give electricity force, you have to put electricity on that for making that reactions to happen. So that type of reactions or process are called as non-spontaneous process. In galvanic cell, the chemical reactions, where you can compare the topper students who study by their own, no one has to tell them to study. So those chemical reactions are those who can undergo the reaction by themselves, and as a result of which electricity is produced. But here the chemical reactions are those students who do not study by their own. Okay, so just now put down in the comment section whether you are a non-spontaneous or a spontaneous student. Okay, so non-spontaneous means those who are not studying by their own. Spontaneous is the one who can study by their own. Okay, so I want all of you to comment down right now. Right now, pause the video, comment it, and let's then listen to the next part. Okay, so if it is a spontaneous thing, then it will be having positive. Delta G value is positive. It is non-spontaneous. Okay, so we have studied in thermodynamics also. Delta G is negative if it is spontaneous, delta G is positive if it is non-spontaneous. Okay. Next, anode is positive and cathode is negative. So this one you should remember. This is the reason why I told you that do not define anode and cathode by its charge. It is different in different cells. If galvanic cell is there, anode is negative, if and cathode is positive. If you have electrolytic cell, anode is positive and cathode is negative. So this is the charge of the anode and cathode is dependent on the cell it is present. Then how can we define? So as I told you before also, anode is where oxidation takes place and cathode is where reduction takes place. Okay. So now we will see next thing, that is where this anode or where this electrolytic cells are used. It is used for obtaining pure metals. Now I will give a very good example of this one. So it is generally used in the purification of copper. Okay. So what we do is, you take an impure copper on the anode side. Okay. Impure copper is taken on the anode side and a pure copper is taken on the cathode side. Okay. And then we have here yes, and then we have here copper sulfate solution where you have Cu2 plus ions. Okay. Now you can see this is anode is positively charged, cathode is negatively charged. Then what will happen? What will happen then? Now see, this is positively charged, so it will be attracted towards the negative electrode. So what will happen? This one will go and discharge itself. It will gain electrons there and it will get reduced. At the same time, what will happen? From this rod, copper, impure copper rod is there, the copper metal that is present here will undergo oxidation and come to the solution. Okay. So from here copper will come out and here the copper will deposit. So in this way what will happen? All the impure copper, all the copper that is present in this rod will come out and will deposit on this one. So with time what will happen? This rod is getting thinner and thinner because all the copper is coming out from here, and this rod is getting thicker because copper is getting deposited here, right? So that is your electrolytic application in the purification of metal. So you can see where we have taken the simplest electrolytic cell consists of two copper strips, right? Consists of two copper strips dipping in the solution of aqueous copper sulfate. So you have taken here aqueous copper sulfate. If a DC voltage is applied to the two electrodes, then copper 2 plus ions, right, discharge at the cathode. So this copper, when you give current to this one, the copper 2 plus ion discharge here at the cathode, right? This is the reaction at cathode. Then copper metal is deposited on the cathode. At the anode, copper is converted into Cu2 plus ions by the reaction. So what happens? By which reaction? Cu present in this anode get converted to Cu2 plus and it releases 2 electrons and it converts to Cu2 plus. Now the copper is dissolved, the oxidized at anode and deposited at the cathode. Okay, so Cu2 plus comes out from anode and gets deposited at the cathode. So this is a way how we can purify the metals. There are various other metals also purified in this way. So you can see here, this is the basis for an industrial process in which impure metal is converted into the purity. The impure copper is also, this question is asked many times, the impure copper is taken as anode and the pure copper is deposited at cathode. Okay, so this you have to remember or you have to understand. Impure has to be in the anode side, pure has to be in the cathode side. Okay, students, are you enjoying the class? I hope you are getting everything. If you are getting, then please put down a comment. Yes, I know it is recorded, but still I want to know how many of you are understanding the concepts, you are relating with this, you are able to get the concept easily. Okay, fine. Now let's move to the next one. Okay, can you guess this scientist? Anyone can guess this scientist, or you can just have any instinct about who is this sir or who is this scientist. If you know or if you have any idea, that also you can comment down quickly and just take a pause, think, or you can search, Google it, and then also you can put down quickly in the comment section. Okay, let's have a let us see how much we know those scientists who have made great discoveries in our in the world and are remembered today. Okay, so just let me tell you, he is Sir Michael Faraday. Okay, so why are we studying about it? So many of you might be very thankful to him that he has given so many great inventions, great discoveries to us, while other students might be cursing him for making such discoveries, and they have to study these formulas, these theories for that why these people have created this and why do we have to study, right? So there are different, but yes, we should be really grateful to these people, their knowledge that has helped us to make an advanced society that we live today, right? Okay, so actually he studied about electrolysis in detail. Okay, he has studied so much about electrolysis, and then he gave two important laws of electrolysis in 1833 and 34. This is not a history class, you don't have to remember the years or everything, this is just for some knowledge. Okay, so means you can relate 1833, 34, this Faraday's law, these things came. Okay, so maybe your ancestors' time. Okay, so now if I tell you what is Faraday's first law. So now we have understood that if we pass current, okay, if I give current, electrical energy, there will be a chemical energy, chemical reactions happening in response to that. So now this chemical reaction, what will that do? This chemical reaction will help, okay, this chemical reaction will help this chemical energy can get converted to a chemical reaction. In chemical reaction, what happens? Reactants gets converted to products, right? So he was able to calculate how much current you will give so that this much amount of product can form. So basically, if I tell you, see, if I show the previous one, we have seen we have an impure copper rod and we have a pure copper rod, right? And then we connected it, plus minus, right? Now what will happen? From here the Cu2 plus ions will come and here the Cu copper will get deposited, right? So here this copper mass will get deposited. Okay, any doubt here? No, right? Copper mass will deposited. Faraday was able to calculate that how much current or how much time the current should be passed here and the relation between how much mass is deposited. Okay, understanding how much current and electricity has to be passed here so that to get a certain amount of mass. Okay, or he was saying that according to his law, Faraday's first law, the amount of chemical reaction which occurs at any electrolyte during the electrolysis by a current is proportional to the electricity passed through the electrolyte. So he says that so he says here that the current passed or the current given is directly proportional to the chemical reaction takes place. Okay, when I say that chemical reaction takes place, what happens? Copper is getting deposited, so I can say that is equal to mass deposited. So current passed is directly proportional to mass deposited. Okay. Okay, so students, I am little bit unwell today, so maybe my voice may feel little bit I can say different, so please bear with that. Okay, so fine. So now what I have here, what I can say is that mass deposited is directly proportional to the charge you have given. Okay, M is directly proportional to charge that is passed through the solution or through the electrolyte. Then this charge, if you remember, Q is equal to IT, you might have studied in physics, so I can say IT. Okay, now to remove this proportionality, we multiply a constant Z into I into T. Okay, that is the formula which you see here. Now this Z, is called as electrochemical equivalent. Electrochemical equivalent. And what is it equal to? Molar mass divided by N into 96500. Molar mass divided by N into 96500. What is this N here? N is the number of electrons involved. Like for example, if you have copper, so copper will require 2 electrons. So N factor here is 2. If I have aluminium, it will require 3 electrons. So N factor is aluminium, N factor is 3 here. Okay, so the number of electrons involved in a reaction is your N factor. Okay, so that is your Faraday's first law. But Faraday has also given another law, that is Faraday's second law. And what does the second law says us? The second law says that the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Means, see, now let's consider that. Now let us understand the second law in detail. Okay, so suppose I have 2 chambers. Okay, so here you have electrodes and here you have electrodes. Okay, now you have connected them and you are passing same amount of current to both of them. Okay, you are passing same amount of current to both of them. When we pass same amount of current, what do we call these type of connections? These are your series connection, right? You might have studied in resistance, right? Calculating the effective resistance. Series connection is there. So what will happen? This is anode, this is cathode, this is anode, this is cathode. So here one metal will deposit, let it be copper 2 plus, and here another, let it be aluminium 3 plus. So the law says that if the same amount of current is passed, mass deposited here and mass deposited here. So mass deposited here, M of copper will be proportional to equivalent weight of copper, and we have mass of aluminium will be proportional to equivalent weight of aluminium. Okay, now if I divide these both, I will get mass of copper by mass of aluminium is equal to equivalent weight of copper by equivalent weight of aluminium. Okay, so this is the second law of Faraday's law, which says that if 2 cells are in series or same amount of current is passed in 2 cells, the mass deposited will be proportional to their equivalent weight. Now question may arise, what is equivalent weight? Equivalent weight is molar mass by N factor. N factor again is what? Here N factor is again the number of electrons used. Okay, I hope this is clear. So let's see the formula. M1 by M2 is equal to E1 by E2, where E1 is M1 by N1, E2 is M2 by N2, where N is the number of electrons involved. Okay, number of electrons involved. Okay, and here also I'll write N is number of electrons. Clear? And here one more thing you should remember, that in this time should always be in seconds. The unit of time should always be considered in seconds only. Okay, so we are done with the Faraday's first law and second law. Now here we will know something about charge also. So charge of 1 electron, if you know 1 electron charge is how much? 1.6 into 10 to the power of minus 19 coulomb, right? 1 electron charge is 1.6 into 10 to the power of minus 19 coulomb. Next we have the charge of 1 mole of electrons. Okay, 1 mole of electrons is equal to total 1 mole means 6.022 into 10 to the power of 23. So Na is 6.02 into 10 to the power of 23 into 1.6 into 10 to the power of minus 19. Now if I multiply this, you will get around 96487, or this value is called as 1 Faraday. So what is 1 Faraday? This quantity of electricity is called as Faraday and is represented by symbol F. So what I can now say or define as 1 Faraday? 1 Faraday 1 Faraday is equal to charge of 1 mole of electrons. Okay. For approximate calculations, we use 1 Faraday is equal to 96500 coulomb. So we just round it off and we take it as 96500 coulomb per mole. For the electrode reactions, Mg2 plus 2 electrons gives you Mg, aluminium 3 plus 3 electrons give you aluminium. So here how many, so when I write this 2 electron, it means 2 moles of electron. When I write 3 electron, it means 3 moles of electron, which is equal to 2 Faraday, and this is equal to 3 Faraday. Okay, right? Because 1 mole of electron is 1 Faraday. So 2 moles of electron is 2 Faraday. 3 moles of electron is 3 Faraday. So it is obvious that 1 mole of Mg2 plus and Al3 plus requires 2 moles of electrons, that is 2 Faraday, and 3 moles of 3 Faraday respectively. The charge passed through the electrolytic cell during the electrolysis is equal to the product of the current in amperes and the times in second. That is, I already told you, Q is equal to I into T. And in commercial production of metals, current as high as 50,000 amperes are used, that amounts to about 0.518 Faraday per second. So this is something just for information, don't need to remember this. So that is what is, this is the value of 1 Faraday. Okay. Next we will see about products of electrolysis. Okay. So it depends on what factors. We have 3 important factors on which the products of electrolysis depends. Very, very important. You can get a question on this as well. So first, it depends on the nature of the electrolyte being electrolyzed, which electrolyte you are using. Okay. Second, it depends on the electrodes. The electrodes, whether it is reactive electrodes or inert electrodes. Okay. Next, different oxidizing and reducing species present and their standard electrode potential. Okay, so this factor you will understand when I will explain with example. This will be more clear. Okay, so we'll talk about example of NaCl. Okay, so now if I take simple NaCl, you have a solution. Okay, and you have taken in this NaCl solution. Okay, here what are the ions present? So I'll connect it. This is plus, this is minus. Okay, now here I have Na plus and Cl minus ions. So Cl minus will move to this side and Na plus will move to this side, right? Positive ions will move to negative electrode, negative ions will move towards the positive electrode. And here Na plus cathode is there, it will undergo reduction. Here chlorine is there, it will undergo oxidation at the anode. That is very simple. But what is the case if you take aqueous NaCl solution? Okay, if you take aqueous NaCl solution, what are the ions present? Aqueous NaCl. So you have Na plus, Cl minus, water is also there, it will also ionize, H plus and OH minus. Right. So these two are positively charged and they will move towards the negative electrode, that is cathode, and these two are negatively charged and will move towards the positive electrode, that is anode. Right. Cathode and anode. Now what is there? Who will win? Or both the reactions will not take place. Any one of them will undergo reduction and oxidation. So how do we check that? Here comes the third point that we have talked. Different oxidizing and reducing species present and their standard electrode potentials. Okay. So this point we will explain now. You can see here. So at cathode there is a competition between the reduction reaction. So at cathode we have Na plus and H plus. What is the reduction potential of Na plus? Minus 2.71. What is the reduction potential of H plus? 0 volt. So which is having higher reduction potential? Definitely it is the hydrogen which is having more reduction potential, right? So definitely reaction with higher E0 value is preferred, and that is why hydrogen will undergo reduction here. So which reaction will take place at cathode? Hydrogen reaction will take place at the cathode. But now this H plus is coming from where? H plus is coming from the ionization of water. H2O gives you H plus and OH minus. So the net reaction at the cathode is what? You need to add these two reactions. H plus will get cancelled. Okay, so we will get H2O plus electron gives half H2 plus OH. So this is the net reaction that is happening at cathode. Okay, now let's talk about anode. At anode, the following oxidation reactions takes place. At anode, obviously oxidation will take place, loss of electrons. Chlorine loses electrons to give you Cl2 and H2O loses electrons to give you O2, right? Now, here what will happen? Oxidation is happening. We want oxidation reaction. So the one whose reduction potential is low, it has higher tendency to undergo oxidation, right? Let me repeat it. Two species are there. They want to undergo oxidation. So we know their reduction potentials. So the one whose reduction potential is higher, that will undergo reduction. The one whose reduction potential is lower, that will undergo oxidation. So if you see here, chlorine reduction potential is 1.36 and water reduction potential is 1.23, right? So if I see that chlorine has a higher reduction potential, so it has a more tendency to undergo reduction, and this has a more tendency to undergo oxidation. But what happens? This one should undergo oxidation at the anode, but here there is a catch. This process of oxidation of water is a very slow process, okay, and you have to give more energy, more electricity to carry out this process, okay. So the reaction at anode with lower value of E naught is preferred. With lower value of E naught, this one has to be preferred, and therefore water should get oxidized in preference to Cl minus. However, on account of over potential of oxygen, reaction 2.36 is preferred, okay. So that is what I was saying. This reaction is very slow. It cannot happen with a normal, you have to add some more potential there, okay. With the whatever potential is given, according to that much potential, this reaction cannot take place. It is a very, very slow process. Over potential has to be given. So that we are not doing. So that is why chlorine will undergo oxidation at the anode. But by E naught values, H2O should undergo oxidation, but since it is a very slow process at this normal potentials that is given, it will not take place. Okay, I hope this is clear. So after finally what happens? The net reactions, we have NaCl with water, it gets dissociate to Na plus and Cl minus, and at cathode what is the net reaction we have? H2O gives you electron plus half H2 plus OH minus, and at anode we have Cl minus gives you half Cl2 plus electron. So now the final reaction that we have is NaCl. So if you just add all this, okay, so we have I can add all these reactions. Cl minus will get cancelled, electron will get cancelled. Then we have yeah, I think that's all. So I have NaCl plus water, okay, gives Na plus OH minus plus Cl2 gas plus H2 gas, and these two can be written as NaOH. Okay, this can be written as NaOH. Okay, NaOH we can write here. So the product will be NaOH plus half H2 plus half Cl2. Okay, so like this we have different examples. So first we have dilute H2SO4 and concentrated H2SO4. So in dilute H2SO4 we have water, so that is why at cathode hydrogen gas is produced and oxygen at anode. And if you take concentrated sulfuric acid, hydrogen gas will be produced at cathode, and we have S2O8 gas produced at anode. You can see the reactions also. Okay, these are certain examples which is given in your book. Similarly, we have molten NaCl and aqueous NaCl. This we have already discussed. Okay, so that's all in this today's class, products of electrolysis, and now it's time to solve some questions and practice what we have studied today. Okay, so let's come to the first question here. Question number 1. You have 4.5 gram of aluminium is deposited at cathode from a molten electrolyte containing Al3 plus ions by a certain quantity of electric charge. So what is the first question saying? You have a molten electrolyte, okay, where we have aluminium 3 plus. Okay, now here what happens? 4.5 gram of aluminium is deposited at cathode. Okay, so how much cathode is deposited here? We have how much aluminium is deposited? Sorry, we have 4.5 gram of aluminium deposited. By a certain quantity of electricity charge. We don't know how much amount of electricity charge is given, but with a certain amount of electricity charge, this much is deposited. Okay. Now the question is saying, if the volume of hydrogen gas that will be produced at STP from H plus ions in a solution by the same quantity of electric charge will be. So now the question is saying, let this current here is I, or the charge electricity passed here is Q. If I pass the same amount of current or electricity in another chamber, okay, where I have H plus ions, okay, then how much volume of H2 gas will be evolved? I hope, are you getting the question? The question is saying a certain amount of current was passed and we got 4.5 gram of aluminium. The question is saying, if I give same amount of current to a solution containing H plus, then how much gram of H2 will be released here? Okay, that is the question. So let's try to solve this. Whenever same current is given, can I use Faraday's second law? What is this? I can write mass of hydrogen by mass of copper is equal to equivalent weight of hydrogen by equivalent weight of copper. Right, I can write this one. So what is the mass of hydrogen deposited? That I have to calculate. Okay, mass of, sorry, not copper, this is aluminium. Okay. Here I will change it to aluminium. Oh, sorry, it is given aluminium, right? So let's write down mass of aluminium by equivalent weight of aluminium. So we have mass of hydrogen, mass of aluminium will be how much? How much is deposited? 4.5 gram. Next, equivalent weight of hydrogen. What is the equivalent mass of hydrogen? You can see 2H plus will require 2 electrons to give you H2, right? So that means what is the mass formula for equivalent mass? Equivalent mass is molar mass by the number of electrons used. Molar mass of hydrogen is 2, number of electrons used is 2, so this is 1. So equivalent weight of hydrogen is 1. And what is equivalent weight of aluminium? So aluminium we have, okay, so what is the equivalent mass here? It is 27 by 3. Okay, 27 is the molar mass, it is already given in the question, and you have 3 electrons involved, so this is 9. So I will substitute here 9, right? So if I solve this, what is the mass of hydrogen I am getting? Mass of hydrogen will be 0.5 grams, right? So how much hydrogen is formed here? 0.5 grams, right? But the question does not end here, because it is asking about volume of hydrogen that is produced, right? So if I want volume of hydrogen, then can I convert this to volume? Yes, we have studied in mole concept how to convert, right? So first we will convert it into number of moles of hydrogen. Number of moles of hydrogen will be what? Given mass by molar mass. What is given mass here? 0.5. And what is molar mass here? Hydrogen molar mass is 2. Then what is volume of hydrogen? So to convert moles to volume, multiply with 22.4 liter. We know 1 mole is how much volume at STP? 22.4 liter at STP, right? So I can convert volume of hydrogen will be 0.5 by 2 into 22.4. So I can just solve this. 5 2s are 10, 5 1s are 5, plus 1 6, 56. I'll get 5.6 liter, which is option number D here. Okay. Next, we'll see question number 2 here. What is the weight of copper will be deposited by passing 2 Faradays of electricity through a cupric salt? Cupric salt means what? The charge of copper is 2 plus, right? So if I have, this is the reaction I have, right? So if I pass 2 Faraday, then how much copper I will deposit? 1 mole, right? 1 mole of copper is 63.5 grams. So with 2 Faraday, how much I can deposit? 63.5 grams. Next, during the electrolysis of aqueous sodium chloride, the anodic reaction is. During the electrolysis of aqueous sodium chloride. So if you have aqueous sodium chloride, okay, so that means you have Na plus, Cl minus, H plus, OH minus, right? So if I have aqueous sodium chloride, the anodic reaction is anode. Okay, so this one will move and this one will move towards the anode, and just now we have seen that chlorine will undergo the reaction because of the over potential of water. So that is why oxidation of chlorine will take place. Okay. Next, we have calculate the weight of the metal deposited when current of 15 ampere, okay, is passed with 75% current efficiency for the cell for 2 hours. Okay, so here we will again use the formula Faraday's first law. M is equal to Z into I into T. Okay, here you should remember time is in seconds, right? So now if I do Z, the electrochemical equivalent is already given to me. Okay, this is done. Current is 15 amperes but 75% efficient. That means 75% of 15 amperes. Okay, that is the current here. Time is 2 hours. So 2 hours means 30. You should convert it into seconds. So 1 hour is 3600 seconds. So that will solve. So this is the final calculation you have to do. That is 4 into 75 into 15 into 2 into 36 into 10 to the power of minus 4. So if I solve this, I'll get 32.4 gram, which is my option number A here. Okay. Moving to the next one, the products formed when aqueous sodium chloride is electrolyzed. So we have already seen in aqueous electrolyte we have sodium hydroxide, hydrogen and chlorine. That is option number D here. Okay, so after this 5 questions, I have given you some 3 questions homework. Okay, so do try out these questions. The solutions is also given, but yes, do not cheat. First solve it and then you check the answers. And that's all in this class. Thank you for watching and do not forget to subscribe the channel. Thank you all of you and all the best.